Welcome to Dr. Carminati's channel. I'm thrilled you're joining me today for what might be the most groundbreaking topic we've ever covered, Microsoft's Majorana quantum computing chip. Imagine a future where computers can solve problems so complex that today's fastest machines would take millions of years to crack them. That's the promise of quantum computing, and Microsoft's Majorana chip is a giant leap toward making that future a reality. Whether you're a tech enthusiast, a curious learner, or someone who wants to stay ahead of the curve, this video is for you. If you're new here, please subscribe and hit the notification bell so you don't miss out on more deep dives into cutting-edge technology. And as always, I'd love to hear your thoughts. Drop a comment below, like this video if you find it helpful, and let's start a conversation. Now let's dive into the fascinating world of quantum computing. Don't worry if you've never heard of it before. I'm going to break it down step by step, so by the end, you'll feel like a pro. First, let's talk about what makes quantum computing so different from the computers we use every day. Think about your laptop, smartphone, or even the supercomputers used by scientists. At their core, they're powered by bits, the smallest units of information. A bit is like a light switch. It's either on or off, representing a 1 or a 0. Every task your device performs, from sending an email to streaming a video, boils down to billions of these ones and zeros zipping around in complex patterns. This system, known as classical computing, has been the backbone of technology for decades, and it's served us incredibly well. But here's the catch. Some problems are so mind-bogglingly complex that even the most powerful classical computers would take longer than the age of the universe to solve them. These are problems like simulating how molecules interact to create new medicines, optimizing traffic flow in massive cities, or even predicting weather patterns with pinpoint accuracy. That's where quantum computing comes in, and it's a total game changer. Instead of bits, quantum computers use something called qubits. Now, qubits aren't just 0 or 1, they can be 0, 1, or both at the same time. This is thanks to a property called superposition. To help you picture it, imagine flipping a coin. While it's spinning in the air, it's not just heads or tails, it's in a state of being both until it lands. That's superposition in a nutshell. A qubit can exist in multiple states simultaneously, allowing it to process a vast number of possibilities all at once. But wait, there's more. Qubits also have another superpower called entanglement. When two qubits become entangled, they're linked in a unique way. Change the state of one and the other changes instantly, no matter how far apart they are. It's like having a pair of magic dice. Roll one, and the other automatically shows the same number, even if it's on the other side of the world. This connection allows quantum computers to perform incredibly complex calculations at speeds that classical computers can't even dream of. These two properties, superposition and entanglement, are what give quantum computers their jaw-dropping potential. They can tackle problems that are practically impossible for classical machines, like designing new materials for renewable energy, cracking codes that protect sensitive data, or even modeling the behavior of subatomic particles. But building a quantum computer isn't easy. Qubits are incredibly delicate, and even the slightest disturbance, like a tiny temperature change or a stray electromagnetic wave, can cause errors. That's why companies like Microsoft are racing to develop more stable, reliable qubits, and their Majorana chip is a significant milestone in that journey. In February 2025, Microsoft made headlines by unveiling the Majorana 1 chip, the world's first quantum processor powered by topological qubits. I know that sounds like a mouthful, but stick with me, it's worth understanding. Most quantum computers today use regular qubits, which are notoriously fragile. Even the tiniest disturbance can cause errors, making it challenging to build reliable quantum systems. Microsoft, however, took a different approach. Their topological qubits are constructed to be more stable and less error-prone, which could be the key to making quantum computers practical for everyday use. Why is it called the Majorana chip? The name comes from Majorana particles, which are these elusive subatomic particles that physicists have been hunting for decades. Here's the cool part. Majorana particles are their antiparticles. Typically, a particle and its antiparticle, like an electron and a positron, destroy each other if they meet. But Majorana particles are their own mirror image, which gives them a unique kind of stability. Microsoft figured out how to create and control these particles using a unique material called a topoconductor, made from indium arsenide and aluminum. By weaving these Majorana particles into their qubits, they've built a system that's naturally resistant to errors. It's like giving the qubits a suit of armor, protecting them from the chaos of the outside world. This topological approach is a big deal because it could solve one of the biggest headaches in quantum computing: error correction. In traditional quantum systems, you need a ton of extra qubits just to check and fix mistakes, which makes scaling up really tricky. However, with topological qubits, error protection is built right into the hardware so that you can get more computing power with fewer qubits. Microsoft's Majorana 1 chip is designed to scale up to 1,000,000 qubits on a single chip, way more than what's possible with current technology. That's a huge step toward building quantum computers that can tackle real-world problems. But what does this mean for you and me? Let's explore how Microsoft got here and what this technology could mean for fields like artificial intelligence and cybersecurity. Let's take a quick trip back in time to see how Microsoft got here, because this didn't happen overnight. Their quantum journey started around 2006 when they decided to bet big on topological quantum computing. While other tech giants like Google and IBM focused on superconducting qubits, Microsoft took a riskier path, believing that topological qubits would be the way to go for long-term scalability. They hired top physicists, built dedicated labs, and formed partnerships with companies like Quantinuum and Atom Computing to accelerate their research. These collaborations were crucial, giving Microsoft access to cutting-edge technologies and expertise. A breakthrough came in May 2023, when Microsoft published a peer-reviewed study showing they could create and manipulate Majorana zero modes, the building blocks of their topological qubits. That was a turning point, proving their approach wasn't just theoretical. Then, in February 2025, they unveiled the Majorana 1 chip, a real working quantum processor that could change everything. Microsoft's involvement in DARPA's Underexplored Systems for Utility-Scale Quantum Computing (US2QC) program also played a key role, pushing them closer to their goal of building a fault-tolerant quantum computer. Now let's talk about what this means for the stuff we care about, like artificial intelligence. Quantum computing and AI are a match made in heaven. AI, especially machine learning, thrives on processing massive amounts of data and finding patterns that humans can't see. Quantum computers, with their ability to handle multiple possibilities at once, could supercharge AI in ways we can barely imagine. For example, in drug discovery, scientists often need to simulate how different molecules interact to find potential treatments. This is incredibly time-consuming on classical computers, because the number of possible interactions is astronomical. A quantum computer with the Majorana chip could simulate these interactions in a fraction of the time, potentially leading to breakthroughs in medicine. Imagine finding new treatments for diseases like cancer or Alzheimer's faster than ever before. That's the kind of impact we're talking about. Another area where quantum-powered AI could shine is in financial modeling. Imagine being able to analyze global markets, optimize investment portfolios, or predict economic trends with unprecedented accuracy. Quantum computers could crunch through vast data sets and complex algorithms at lightning speed, giving businesses and governments a serious edge. Even in climate science, quantum AI could help design new materials for solar panels or batteries, making renewable energy more efficient and affordable. The possibilities are endless, and Microsoft's Majorana chip is paving the way for these advancements. But let's not forget about cybersecurity, because this is where things get really interesting and a little scary. Quantum computers, including the Majorana chip, pose a serious threat to the encryption methods we use today. Most online security, like the locks on your bank account or email, relies on math problems that are hard for classical computers to solve, such as factoring large numbers. A powerful quantum computer, though, could crack these codes in no time using something called Shor's algorithm. That means sensitive data, from personal information to national secrets, could be at risk if quantum computers fall into the wrong hands. Here's the twist. Quantum computing also offers a solution to this problem. Researchers are already working on post-quantum cryptography, which are new encryption methods designed to withstand quantum attacks. There's also something called quantum key distribution, QKD, which uses the principles of quantum mechanics to create communication channels that are virtually unhackable. If someone tries to eavesdrop, the system detects it immediately, thanks to entanglement. Microsoft, with its Majorana technology, is in a prime position to lead the development of these next-generation security solutions. So, while quantum computing might shake up cybersecurity, it could also make it stronger than ever. Now, you're probably wondering, when can we actually use this technology? Microsoft's Majorana chip is still in the research phase, so it's not something you'll find in stores anytime soon. But the company has laid out a clear roadmap for the future. They've divided their quantum journey into 3 stages: foundational, resilient, and scale. In the foundational stage, they've already achieved key milestones, like engineering topological qubits. The Majorana 1 chip marks their entry into the resilient stage, where they're focusing on creating logical qubits that can handle real-world tasks without breaking down. Their ultimate goal is the scale stage, where they'll build a quantum computer with 1 million qubits capable of solving problems that are currently unsolvable. When will that happen? Microsoft says practical quantum computers are years, not decades away, which is a pretty bold claim. They're also part of DARPA's US2QC program, which aims to develop a fault-tolerant quantum computer by 2033. For us, regular folks, quantum computing will likely first become accessible through cloud services like Azure Quantum, possibly within the next 5 to 10 years. That means businesses and researchers could start using quantum power without needing to own a physical machine. Standalone quantum computers might not hit the market until the 2030s, but the impact will be felt long before then. Let's wrap this up with a look at the bigger picture. Microsoft's Majorana chip isn't just an incredible piece of tech, it's a glimpse into a future where quantum computing transforms how we live, work, and solve problems. From curing diseases to securing our digital lives, the possibilities are staggering. And here's the best part. We're just at the beginning of this journey. There's so much more to discover, and I can't wait to see where it takes us. Thank you for joining me on this deep dive into quantum computing and Microsoft's Majorana chip. If you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to Dr. Carminati's channel for more adventures in cutting-edge tech. I'd love to hear what you think. Drop a comment below and tell me what excites you most about quantum computing. Let's keep the conversation going.